YouTube online lecture. Today we're looking at work done in an electric circuit. If you are seeing this video for the first time, kindly subscribe by pressing on the or by tapping on the subscription icon. That looks like a tiny bell below the YouTube name, and get subscribed for once, and then get that video from time to time. So we're now looking at work done in the electric circuit. So in physics or electricity, work is done when a charge is moved or when a charge is moved from one point in a circuit to the other. As we defined in earlier video, we'll say that the potential difference is the work done in transferring a unit positive charge from one point to the other. So in physics, work is done when charges are transferred from one point to the other in an electric circuit. And the work done in a circuit, you know the formula QV, where Q is charge measured in coulombs and V stands for potential difference measured in volts. I will know from knowledge in physics that Q, current, is Q over time, and then making Q the subject, charge becomes current times time. Then substituting this formula IT in this equation, when I say work equal to ITV or IVT, as you may write it, replacing Q with IT. We have formula for work done in an electric circuit. So the work done in a circuit is given by IVT or QV. Then, if you recall Ohm's law, let's rewrite this up here. Work done is IVT. From Ohm's law, current is voltage over resistance. And also for the same Ohm's law, voltage is current times resistance. So if I substitute current with V over R, work done becomes, replacing I with V over R, I have V over R times VT. Replacing I with V over R, I have that substitution. And I have V squared T over R. This is also another formula for work done in the circuit. Or if I go up there and substitute voltage with IR, I have I multiplied by IRT. What have I done? I replace the potential difference with IR. So I now have work done also as I squared RT. So the work done in a circuit given by either IVT, V squared over RT, or I squared RT. The work done in an electric circuit is stated as the heat generated or the heat dissipated in a circuit, because work and energy are synonymous. Work and energy are the same, they have the same unit, joule. So if you have to find the heat energy dissipated in a circuit, you still apply the same formula, IVT, V squared T over R, or I squared RT. So when you're looking for heat generated in an electric circuit or electrical appliance, or you are calculating the work done in the electric circuit, this formula is, all of them are applicable when I was given to you in the equation. That says, find or calculate the work done in electric filament of resistance of resistance 15 ohms when a current of 5 amperes flows for 30 minutes. To solve this problem, how do we go about it? We are given the resistance as 15 ohms, the current as 5 amperes, the time as 30 minutes. The work done or the heat energy dissipated given by IVT, or we can use I squared RT, or we can use V squared over RT. So the formula that is best for this problem is the Scon equation that provides current, resistance, and time. So now I say work equal to I squared RT, which is current is 5, so 5 squared, resistance is 15, time is 30, and you have to convert the time to seconds to standardize the unit. When we apply everything, we're going to have 675,000 joules of heat energy or work done. So that's the answer to the question. Says an electric lamp is rated 36 watts. I have a lamp rated 36 watts, then 120 volts. Then the question says, calculate the current in the lamp and the resistance. Calculate the current in the lamp and the resistance. So to solve this problem, this 36 watts stands for power, because you know power is watts. So power is 36 watts. And then our voltage of potential difference is 120 volts. We're looking for current. So power in a circuit given by IV. Mind you that power is work done over time. So if the work done in the circuit is IVT divided by time, then I get your power. Power is IV. You see how other formula for power, other formulas for power anyway. So based on substitution with Ohm's law. So you can have power as IV, can have power as I squared R, can have power as V squared over R. Any of them can get power for us. Multiply the power by time, you get back work and energy. So since we're looking for current becomes power over voltage, which is 36 over 120. Looking for current. Divide 36 by 120, we get 0.3 amperes. So the current flowing in the circuit is 0.3 amperes. And we have to find the resistance. How to find resistance? We know our current as 0.3 amperes. We know our potential difference as 120 volts. Looking for resistance. The formula that connects current, PD, and resistance together is the Ohm's law. We can now say that I is V over R. We make R the subject. Resistance becomes voltage over current by cross multiplying. We make R the subject. So your V is 120. Your current is 0.3. So you now have 400 ohms as your resistance. So today, this session, we're looking at electrical power. Power, as we have described earlier on in the previous example, power is the rate of doing work. Power is energy over time or work done over time. The electric circuit, work done can be given as IVT. Substitute work with IVT. Now IVT over time. Power is now IV. Time cancels time. Also, work done is given by I squared RT. Power now becomes I squared RT over time. Time cancels time. We still have I squared R. So this can also take care of power of this equation. Then we can still get power using the formula V squared over R. So any of this can calculate, from any of this formula, we can calculate our power in a circuit. It all depends on what is given to us in the question. We already taken an example on power. Then let's look at this problem on the board. We have this from a past question. We have two resistors. Resistors A and B. This is 4 ohms, this is 3 ohms. Whereas calculate the ratio of the electrical power of the power dissipated in A to B. The ratio of the power dissipated in A to B based on the diagram given to us here, this is the diagram. When we look at this, we see that the two resistors are connected in parallel. As I said, when two resistors are in parallel, they'll have the same potential difference across them. So this potential difference across A and across B will be the same, and that is the V we are seeing there. Then what do? We now get the equation that connects, since we have resistance and VD that connects power through V and R. Power is V squared over R. So that is the equation that connects potential difference and resistance and as well as power. Then for the resistance for A, the power across A will now be given as V squared all over 4. Because resistance on A is 4. We call this equation 1. The power across B will be also the same V squared over 3, where resistance is B is 3. We call this equation 2. We look for the ratio of the power across A to the power distributed in B. We now divide A by B. That becomes V squared over 4 divided by V squared over 3. And that will give us V squared over 4 times 3 over V squared. V squared cancels V, we now have 3 over 4. So the ratio of BA to BB, power in A to the power distributed in B, is going to be 3:4 as our final answer. So we are talking about electrical cause, and electrical cause, that is how in every household at the end of the month we're going to pay taxes. We're supposed to pay tax on the appliance we are using. In a country like Nigeria, we will pay NEPA bill or what we call power holding company, and we pay tax to them every month. But the important thing is how the appliance we use, how are they charged? So we're looking at the electrical costs. You want to know or want to evaluate how the electrical appliance we use in the home, how the cost, the payment we make every month. What formula do we use to evaluate this? We use this formula: electrical cost equal to power times C times T, or expressed in the currency of the country, where P stands for power used, and that power should be expressed in kilowatts. And then C stands for cost. In the smallest unit or denomination here, the cost is in kobo. Then D is time in hours. So the power holding company bills us in kilowatt per hour, kilowatt hour, kilowatt hour, kilowatt hour, written as kWh. So after summing this, the value will be in kobo. So with all this, but if you want your answer to be in naira, which is Nigerian currency, you multiply this and divide by 100, because 100 kobo make a naira. So let's see how this plays out in the next problem we're going to use. We have a problem that says a household refrigerator is rated 200 watts. If electricity costs 5 kobo per kilowatt hour. What is the cost of operating it for 20 days? So this is a jam question. Let's look at this for 20 days. So a household refrigerator is rated 20 watts. So the power is 200 watts, 200 watts. Then the cost is 5 kobo per kilowatt hour. The time is 20 days. So the cost of running an instrument or refrigerator of 200 hours for 20 days at the rate of 5 kobo per kilowatt hour can be calculated using the formula electrical cost equal to PCT over 100 in Naira. And as I said before, this P should be expressed in kilowatt, not in watts. So we have to divide 200 by 1,000 to convert to kilowatt. It will give us 0.2 kilowatt. So we now have 0.2 times the money, the cost should be in kobo. And the time, as I said, should express in days, in hours. Good. So that's going to be 20 times 24 hours. That gives us 480 hours. Now 480 divided by 100. So when we solve this problem, the final answer becomes 4 naira 80 kobo. 4 naira 80 kobo. For operating a refrigerator of 200 watts at 5 kobo per kilowatt hour for 20 days, the man will have to pay 4 naira 80 kobo. We take another question on this. Under the two course that says 5 television sets, each rated 65 watts, 2 refrigerators, each rated 1.2 kilowatts, and electric fan rated 650 watts, and 10 lamps, each rated 40 watts, are connected in series to a house. How much will it cost to run the appliances for 24 hours? How much will it cost to run the appliances for 24 hours at the rate of 15 kobo per kilowatt hour? So, having done this, how do we tackle this problem? To solve this problem, we have 5 TV sets. We have to calculate power first. We need this formula. E is equal to PCT over 100 to express it in Naira, or root 100 and leave it in kobo. They have TV sets. There are 5 of them, and each of them rated 65 watts. So total power will now become 5 times 65. That gives us 325 watts from the TV. 2 refrigerators, each rated 1.2 kilowatts. So the refrigerator The total power now becomes 2 of them, then 1.2 is 1,200 watts because 1,000 watts make a kilowatt. You have to convert this to watt. Multiply by 1,000, you have 1,200. So multiply it by 2, have 2,400 watts. Yeah. Then a fan is one fan. The power is 650 watts. Then 10 lamps. The total power for the lamps is 10. Then 10 lamps rated 40 watts, giving us 400 watts. If you add the powers together to get the total power from the appliances, added together we will have 3,775 watts. 775 watts. So that represents our power. But in this formula, we say that our power should be in kilowatts. So we have to divide this by 1,000 to convert to kilowatts. That would be 3,775 over 1,000. That gives us 3.775 kilowatts. We'll now go to the formula. 3.775, the power in kilowatts. Then the cost per kilowatt hour in this equation is 15 kobo. That is what C stands for. The time, which should be in hours. How many hours? 24 hours. Then divide by 100 to leave our answer in Naira. So when we divide, our final answer becomes 13 Naira 59 kobo. That becomes our final answer to this problem. So in this session, we're looking at resistance, R, and resistivity, rho, that looks like P, that symbol is called rho, of a conductor. Resistance we have defined before in our former video as the opposition. Resistance of a material is the opposition to the flow of electric current. And in our previous video on electricity, we said that resistance is a physical quantity measured measured in terms of unit called ohms. So the SI unit of resistance is ohms, which can be written in this format. That is the number of ohms. Then we have already established the circuit in our previous video, and then resistance, which could be provided by what we know as resistors. Resistors are the instruments that offer resistance to the flow of current. And we say that we have standard resistor and variable resistor in every circuit. Okay, having done that, having defined resistance, then what are the factors governing the resistance of a piece of wire, of a conductor? So factors affecting resistance of a conductor include: 1, length of the conductor. The length of the conductor, which could be a piece of wire. So the resistance of a conductor vary directly as its length. What it means is, the longer the conductor, the higher its resistance. The longer the conductor, the higher the resistance it offers to the flow of current. The shorter the conductor, the lower its resistance to the flow of current. The other factor that governs resistance is what's called cross-sectional area. Cross-sectional area, we can write as A. Resistance of a conductor varies inversely at the cross-sectional area. So what do we understand by cross-sectional area? If we take a piece of wire or conductor. The cross-sectional area of this structure drawn on the board is nothing but the area of the cross-sectional end, which is circular in nature. And the cross-sectional area of the wire is given by pi r square, with the area of a circle, since the end of the wire is circular in nature. So, what I'm trying to say, if resistance varies inversely at the cross-sectional area, it means that the wider the area, the smaller the resistance. Or the bigger the area, cross-sectional area, the smaller the resistance. The wider the area, the smaller the resistance. The smaller the area, the bigger the resistance. The other factor that affects the resistance of the wire is nature of the material of the wire. So, nature of the material of the wire. What kind of material was used in constructing the conductor or wire? Some materials are better conductor than others. Like copper is an excellent conductor. Silver is the best conductor we have in physical sciences. So, if the material is made of a good conductor, resistance to flow current will become small. When the material is made of a poor conductor, resistance to the flow of current will decrease. Now, having understood the factors governing resistance of a wire, let's look at now this first and second part, length and area. Resistance varies directly as length and inversely as area. If you bring these two expressions together, we now have resistance varies directly as length and inversely as area. Bring these two expressions together form a variation. Resistance varies directly as length and inversely as area. Now, I will know from my knowledge of mathematics that when you have a variation expression, we're going to remove the variation sign and bring proportionality sign and bring in a constant. When I have r equal, the constant I'm now bringing is like letter P, rho L over A. That constant rho we introduced before is called the resistivity of the wire. The resistivity of the conductor. In physics, how do we define resistivity? We say that resistivity is the resistance of a uniform unit length of wire of unit cross-sectional area. Resistance offered by a uniform unit length of wire of unit cross-sectional area. Let's go back to the diagram we drew to represent a piece of wire. For us to talk about resistivity of this wire, it means that this wire should have a unit length, perhaps a length of 1 meter or 1 centimeter. That's the unit length. And then the area of the end should be 1 cm squared. So the length, a wire of 1 cm or 1 meter, an area of 1 cm squared or 1 meter squared. Resistance it offers is called the resistivity. So resistivity refers to the resistance offered by a wire that possesses these characteristics: length of 1 cm or 1 meter, and area of 1 cm squared or 1 meter squared. Let me know the word unit. Now, going back to our expression there, if we make resistivity the subject of the formula by cross multiplying this, we now have rho equal to Ra over L, making the resistivity the subject. We now want to derive the standard SI unit of resistivity. The unit of resistance is ohm. The unit of area is meters squared. The unit of length is meters. So meter cancels meter. We now have ohm meter. So the SI unit of resistivity is ohm meter. That's the unit of resistivity. Although sometimes we can express it in ohm centimeter, but the standard unit of resistivity is ohm meters. That's ohm times meter. So this is the unit of resistivity. Another term we encounter in physics is called conductivity. Conductivity. So what is conductivity in physics? Which I can represent using C. Conductivity is the reciprocal of resistivity. Conductivity, I come again, is the reciprocal of resistivity. That means conductivity is given by the inverse of resistivity, 1 over resistivity. So if from this formula above, resistivity is resistance times area over length. That means conductivity now becomes, if you take the inverse, becomes length all over resistance times area. So you see the difference between resistivity and conductivity in terms of formula. Now, if we want to get the SI unit of conductivity, what we'll do is this. We'll now go to the formula C equal to L all over RA. Replace unit of length is meters, resistance is ohm, area is meter squared. So 1 of the meter cancels 1 here. We're now left with 1 over ohm meter. So the SI unit of conductivity now becomes ohm meter raised power minus 1. Or we can write it in this form: ohm raised power minus 1 meter raised power minus 1. So this is the SI unit of conductivity derived from resistivity. Okay, let's still go back to our resistivity once more as you look at our working on the board. We still go back to resistivity again. So from the formula of resistivity, or we know how this on the board, resistance given by rho L over A. That is the connection between resistivity, resistance, length, and cross-sectional area. Then if you make rho the subject, resistivity, rho becomes RA over L. We can get some derivation from this equation. We know that our a cross-sectional area of wire is given by the formula of a circle, which is pi r squared. So we can replace this here. Now this becomes equal to r pi r squared over L, where pi r squared stands for the cross-sectional area of the wire. Rho equal to r, pi r squared is our A. And also, if you give the diameter of the cross-sectional area, we know that diameter is equal to diameter over 2. So if the area of wire is given by pi r squared, we can replace the radius with d over 2. We now have pi into d over 2 all squared. That will give us pi d raised power 4 all over 4. So that is d over 2 times d over 2. That will give us, d squared all over 4. So that is the under expression for area. Then going back to what we wrote before, here, that resistivity is given by R A over L. Instead of using pi r squared for our area, we can also write it as R, replace area with pi d squared all over 4L. So if you substitute area, we now have pi d squared over 4L in this equation or formula. So resistivity can also be given as R pi d squared over 4L or R pi r squared. These are the first R is resistance, the smaller R is radius over the length of the wire. Or from here, R A over length of the wire. So now we're going to look at some past questions on this topic. Okay, let's look at this problem on the board that says number 1, an SSCE wire equation that says calculate the resistance of a meter length of wire of cross-sectional diameter 0.22 millimeter and resistivity 44 times 10 to the minus 8 ohm meter. So in this problem we have on the board, we are looking for resistance, which is R symbol, and then the length of the wire, we are told that the length is a meter, that is 1 meter. Then we are given the diameter of each cross-sectional end as 0.2 millimeter. So since we are given the diameter of the cross-sectional end, we can find the radius. Radius is diameter over 2, which is 0.2 over 2, which gives us 0.1 millimeter. You look at the unit, the length is in meter and the radius is in millimeter. So the two of them cannot work together because they are not in a uniform unit. So we're going to convert the radius to meters. So how to convert millimeter to meters? We divide by 1,000 because 1,000 millimeter make a meter, or multiply by 10 to the power minus 3. Same effect. Divide by 1,000, which is the same thing as multiply by 10 to the power minus 3. That gives us, if you solve, that gives us 1 times 10 to the power minus 4 meters. Now, having done that, we'll go ahead and find the area of the wire. The area of the wire given by pi r squared. We are taking pi as 22 over 7. We now have 22 over 7 as our pi times the radius 1 times 10 to the power minus 4 all squared. You open the bracket, our area becomes pi. 22 over 6 is approximately 3.14 or 142. Then open the bracket, you have 1 squared is 1. Then 2 times minus 4 gives us minus 8. Look at how I open it. 1 squared is 1. Then 2 times this gives you minus 8. Or you can use calculator as well. So the area of the wire is this in meters squared. So we have gotten our area. We know our length. We go back to the equation. We say resistivity of the wire is this. So our resistivity is 44 times power minus 8 ohm meter. So what are we looking for? We are asked to find resistance. We know our length. We know our area. From the radius we got our area. We know our resistivity. We are looking for resistance. We now ask ourselves, how the resistance connect to length, resistivity and area? From what we introduced earlier on, resistance is rho L over A. So we're looking for resistance. So resistance now becomes, the value of our resistivity is 44 times power minus, already expressed in the SI unit ohm meter. No need to convert anything here. Our length is 1 meter. And then our area of the wire is 3.14 power minus 8. So that's what we have there. So 3 power minus 8 cancel power minus 8. We now have 44 divided by 3.142. And that will give us approximately 14 ohms. So the wire has resistance of 14 ohms. And that is the answer to the question. So you take a look at our solution as we go to the next question. We go to the next is a wire of 5 ohms resistance is drawn out so that its new length is 2 times the original length. If the resistivity of the wire remains constant and the cross-sectional area is halved, the new resistance is, so did the recent university entrance examination, as you can see here, university, tertiary matriculation examination. So have option A 40 ohm, B 20 ohm, C 10 ohm, and D 50 ohm. So let's go to the question. A wire of resistance 5 ohm. So let's call the resistance, the initial resistance of the wire R1 as value is 5 ohms from the equation. Is drawn out so that its new length is 2 times original length. So let the original length of the wire be equal to L. Then the new length be L. Then L to now become 2L is to Y the original length. If the resistivity of the wire remains the same. Now the resistivity of the wire does not change in this condition. So let resistivity be equal to rho or any letter I want to use. Then let this one also be same rho because resistivity remains constant. And the cross-sectional area is halved. So let the area of this wire A1 be equal to A. Then the second condition, the area becomes A over 2 halves of the first one, or 0.5A. Then I say we should find the new resistance. So looking for R2, unknown for us, or let's call it R, unknown value. So we have two sets of conditions here, So how do we solve this problem? Record that resistance of wire again by resistivity times length all over the area. We're going to use this to get an equation for this. So we now have first of all, before we go ahead, since we'll ask ourselves in these two conditions, what they have in common? What is common among them? They have the same resistivity. So we'll make resistivity the subject first. So resistivity, which is rho, begin by Ra over L. So having done that, we'll now substitute our values. Rho, or as I want to call it P, equal to the value of our resistance in this first condition is 5. Our area is taken as A. Our length is L. We call this equation 1. We go to the other condition for the wire. It's using the same equation. Resistivity is equal to Ra over L. We substitute. Resistivity becomes the value of our resistance is unknown, which is what we are looking for. The area is 0.5A because we are told that it's half of the original area. All over the length is 2L. We are told that the length is to Y the original length. Can call this equation 2. So go through it. So you can take a look at before we continue solving. Take a look at what we have done so far. Okay. So since this is resistivity and this is also resistivity, and we are told that resistivity of the two wires remain the same. So P1 is equal to P2. That means equation 1 and equation 2 should be made equal to each other. So we now equate the two. So equation 1 and 2 are equal. Equation 1 is 5A over L, which is the equation 1 for value for resistivity. And equation 2 is R times 0.5A over 2L. Remember that the wire has equal resistivity, that is rho 1 equal to rho 2, as we have said before earlier on. So looking at this expression now, A cancels out A, and length cancels length. We now have 5 over 1 equal to 0.5R over 2. We cross multiply and make the new resistance the subject. Now 0.5R times 1 gives us 0.5R, and 2 times 5 gives us 10. New resistance becomes 10 over 0.5. Solving, that gives us 20 ohms. So the new resistance of the wire is 20 ohms. When I go to the solution, the answer to the equation is option B, 20 ohms, the new resistance of the wire. So that is it on this topic. So always remain focused to this tutorial channel and then subscribe if you are not subscribed to the channel. Remain focused as we bring in more tutorial on physics, chemistry, further maths. You can share our videos in a class group, in a WhatsApp group, on Facebook. Our questions can see inbox us on the YouTube. Questions or topics that you feel that we have to treat for your own understanding. Thank you.